Hello everybody and welcome. Today we're going to look at unit testing. You've probably seen unit testing before elsewhere in the curriculum. So if you have and you're pretty comfortable with it, feel free to just skip over this one because it's not going to be anything new. But I'll show you some of the basics of writing unit tests to test your functions, some of the smart edge cases you might test for, how you might use unit tests in order to detect maybe things that are outside of the description of the functions or catch edge cases and so forth. And this is probably the primary purpose of unit tests, is because when we write our code, we don't think of everything. Now, when you're starting out as an amateur programmer, probably the order that you typically write your programs in is first you write the code, then you write the documentation, and then you probably don't write tests at all. But when you become a professional programmer, or at least many professional expert programmers do that in the exact opposite order. They write the test first, or the documentation, one or the other. Then they write the other one. So the test, the documentation, and then last, they write the code. You might ask how you do that. How do you know what the function is going to do before you've written it? And that's where the zen of programming really comes into play. It's that your goal is to describe what you're trying to do to yourself, show what it is that you want to achieve by writing a test that fails, but should pass once you're done, and then write the function that causes the test to pass. And this process is often called test-driven development. All right, let's get into it. We're only going to test built-in functions today, so we'll look at stuff that you're probably already familiar with, stuff that's from the Java library. So let's look at if we were going to test array sort test. So let's say that you've written your own sorting function, you're probably going to want to do it similarly here. So let's create ourselves a test array. It's very common when we're designing tests to create some test case like this with just placeholder values that we come up with. So it's not like these are anything special. I've just created an array with some numbers in any particular order. And if I was to sort this array, I would expect the result to look like this. So I'm going to say expected, and then I'm going to say what I expect it to be. Well, there's a 1, then a 2, then a 3, then a 4, then a 5, and then a 9. I think I caught them all. Let me do the spacing side by side so I can see if I missed any. It looks like I'm missing 1. Yep, I'm missing that 6 there. All right, so if I had it in ascending order, that is what I would expect the result to be. So let's execute the function that we think is going to sort our test array, what I called R here, and then compare it against our expectation and see if we get what we thought we would. So I'm going to use the built-in arrays.sort. There's actually a bunch of built-in different arrays.sort. If you've been studying sorts in data structures and algorithms, you'll probably remember a few of these. You've got your parallel sort, which is a merge sort. You've got your basic sort, which I believe is quicksort. Let me see. Yep, it's a dual pivot quicksort. O of n log n performance, lovely. And the merge sort also, obviously, O of n log n. And then you've got a couple of other exotic sorts, I think. But let's just stick with the regular sort. So you pass in the array that you want to sort, in this case R, and it will actually mutate it, sort it for you. All right, so at this point, the expected should equal our actual, our R array. So what we want to do is assert that that is the case. So let's do assert dot, what do we have? Assert array equals probably works here. Yeah, let's do assert array equals. That needs to be imported. All the, let's call them luxury assertions, the ones that aren't just the word assert, require you to import them. So we want to assert that the expected array is equal to the actual. All right, lovely. We could also have asserted one item at a time. So we could say for int I equals 0, I is less than length, plus plus, so we assert that each item in the array is equal. So let's do a regular assert equals there, and that would be expected of I and R of I. And I believe I spelled expected wrong. Yes, I did. Okay, and again, all the extra asserts need to be added to the imports. Eclipse will recommend that for you if they aren't already. And last but not least, I could have used, rather than one of those fancy asserts, I could have just used the regular assert statement. That's the one that comes with the JUnit suite. I did actually skip over that part. Maybe I should get even deeper into the starter. So the first step when you're adding tests to your program is to click on the package, go to New, go to JUnit test case, name the class. Generally, you put all your unit tests in one class, but some people also like to put the unit tests that correspond to the functions right there in the same class where those functions are. That's perfectly fine as well. Some people like to organize all their unit tests into a single class file. Some people like to have one class file of unit tests for each class file that the functions are in. So if you have a class called foo, you've got a class called foo tests where all the tests sit. Organization's up to you, depends on the place, but yeah, you would name it, you'd create this, and then you would end up here. If it's your first time doing this for that project, Eclipse is going to ask you if you want to import the JUnit suite. Say yes, and then you're on your way. So if you've gotten to this step, if you've brought this project into your Eclipse or your IntelliJ or whatever, and it's got errors because these imports are failing, try just adding a JUnit test case to the package, and then it will offer you to import that JUnit test suite, and then you can go ahead and delete it because all of these imports should work after that. All right, so back to where we were, the boilerplate assertion that comes with the JUnit test suite is just to assert that the contents of those parentheses are true. So it's basically like an if statement. It's like an if, and then what's inside those parentheses is untrue, then the test fails. If it's true, then the test continues on. So pretty much the same thing as assert equals, just that we have to be explicit and say that we want expected of R to actually equal it. So these are actually identical. This is just a shorthand that is a little bit easier to read, in my opinion, because it shows you that assert equals in plain English in the front versus you having to spy the equal sign a little further along here. But you can do all of your assertions with just the simple Boolean here. And of course, both of these are harder to read, in my opinion, again, than the simple assert array equals, which is a convenient utility that does, again, exactly this, compares them one item at a time, but does so in a single line. All right, so if we run this, we're going to see a beautiful green, meaning that our test passed. Let's say that we were expecting something different. Let's say that we were expecting a 9 and then a 6. This obviously isn't sorted order. If I ran this, we would see some red, and we can follow along. It just occurred to me that the red part's not on the screen, so let me move it over here. Okay, so it's this is the little JUnit, what should we call it, window that pops up. So if you see red, that means your test has failed. You can now click along and figure out where it is that it was unsuccessful. So it was this assertion that failed that caused the test to fail, and you can now try to figure out what was going on there. If you click on the topmost thing, it'll give you a pop-up here. Whoopsie. Okay, not for the array one, but let me try for the individual ones. Oh, yeah, if you look at the topmost thing there, it will tell you the expected value and then the actual. So it's telling you what it got on the left and what it got on the right. So on the left-hand side, expected of I evaluated to 9, but it should have been a 6. So what we're expecting, what was inside of R of I, was actually a 6. So the sorted version should have had a 6 there. Instead it has a 9. All right, that's a basic test case. 6, 9, put that back, run it again. What's going on here? Oh, deleted my import. There we go, green, good to go. That's a very basic test case for sorting. Let's see, what else can I do? What other functions does sort support? I'll try this again on some strings, maybe? Let's try it on some strings. We'll just call this strings. Cake. Cake with a capital C. Bake. and snake. What order should these get sorted in? So I will say expected, I think, oopsie, string expected. I think the lowercase should come last. So it should go bake, cake, snake, and then lowercase snake, lowercase cake. Only last. Okay. Oops, renamed it. Alright. So if I sort my strings, well, let's try the parallel sort, why not? So we've already tried the regular sort on integers, let's try the parallel sort, see if we get different answers. And then I'm going to assert array equals again. Let's see what happens. So it will be the expected strings with the ones we got. And we have a pass. Cool. Now let's do the same thing but with a for loop. Let's use this regular assertion here and assert that expected strings of I equals strings of I, right? Run and pass. This is kind of like a hit and miss in Java, right? You're not supposed to do string comparison with equals like this. What you really ought to do is dot equals like so. Dot equals like so. Now let's look at an example where this equals will fail. I'm going to redesign the test. So I'll call this, they always have to have this @test annotation for the top for them to run along with the suite. And all tests are void, they can't return anything. So I'll call this array string objects. String objects sort test. You don't have to name all of your tests something with test at the end. It's probably a point of contention. You also don't have to necessarily use camel case. You can be consistent with Java and use, you don't have to use snake case. You can be consistent with Java and use camel case names. I like to use snake case, that's underscores between your separators in test names, because when I write test names I tend to make them very long, like this one's 5 words, so it would take a lot of capitals to get it in. Camel case. Alright, so instead of just taking the strings like this, I'm going to have string cake equals cake all lowercase, and then string also cake equals cake all lowercase. So these are the same value. So I'm going to take cake here, and then in the expected strings, I'll expect also cake, which is identical and should not present a problem, right? Let's run it and see. Yeah, all right, cool. So this sort is able to handle the fact that they are different objects that have the same string literal under the hood. But again, this is something that you can never be quite sure of in Java, string comparison. So let's try a couple of other fun objects. Let's do cake dot, let's do a string upper cake equal cake, and then upper cake dot char at we'll change upper cake to cake. Like that. So we'll take upper cake here, and then we'll take cake, the string literal, down there. See if that's still good. Still good. Lovely. Both tests pass. And if your tests pass, it won't show you the list of them. You can always expand this drop down and see all the tests that are running to make sure that you've annotated them correctly and they're actually running. So here it says 2 of 2 passed. I ran 2, all is well. Okay, well, I was hoping to find a fun edge case there, but I didn't. So let's move on to the next thing. Let's try to test some stuff that we know is going to error out. So this is something that we'll commonly do. Let's say divide by 0 exception. We want to test the divide by 0 exception, and we definitely want to annotate that with test so that it'll actually run. Let's start with a string, and call it sandwich. I don't think I spelled that right, but never mind. And then I'm going to say int a equals s.length divided by 0, which of course is going to throw an exception. So if I run this now, that test is going to be read, not because it has an assertion that fails, but because it throws an exception, which is also a failure unless that exception is handled. So what can I do? Well, I can wrap this whole thing in a try and catch. Right, and then I can assert just true down here because I wanted the exception to happen, right? I wanted the exception to happen, and then if the exception doesn't happen, I can just like assert false here so that the test will fail. Okay, so that's kind of the really simple, not so great way to handle exceptions. It's fine if all you want to test is, okay, does this exception? Well, of course it does. Divide by 0 should fail, so it should never reach this line, which will cause this to succeed instead. If you have a multitude of different things that you're wrapping in the same try-catch, you might also want to say like int succeeded. I don't know why I said int succeeded. Bool succeeded equals false. If any of the functions succeed, so if they make it to that line, you can set succeeded to true, and then at the end, if succeeded is true, you can assert false, or you can just assert, for example, not. Succeeded's a hard word to spell. Not succeeded at the end. So assert that none of the things inside of your try were successful. So this is a nice way to handle it as well. I prefer this approach, generally speaking, because when you assert false inside of the try-catch, it then sends you to the catch arm, and it needs to be handled anyway, and that's a little bit confusing, so I prefer to do it this way. You have a flag that's set to false. If something succeeds when it shouldn't, set the flag to true, and then at the end assert that the flag has never been set to true. So this is one way to handle a divide by 0 or any exception with some level of elegance. So a function that you think should have an exception, in this case divide by 0 should have an exception. It's not unusual, it's the expected behavior, and so we want to test that it will have an exception when it's supposed to. But okay, we can get a little bit fancier with it. We can actually get the text of the exception so that we can determine if it failed for the right reason. So let's see, we can declare an exception, which is just another kind of object like everything else, but I do think it needs to be imported here. Well, we'll do that later. And to do that, we can assert throws, and then the body of what we put inside of assert throws will be the thing that we want to check if it errors out. So when you do this, you can either specify generically exception.class, because you need to specify what kind of exception you're looking for, and all exceptions in Java inherit from exception.class. So whether it's null pointer, divide by 0, array out of bounds, all of them derive from exception.class. But they also all have specific ones, like there's, we just talked about out of bounds, null pointer, exception, divide by 0. Those also all have a specific name that you can use. But let's just start with exception.class for now, and then we'll move to the other ones later. There's this fancy syntax that we use that I'm not going to get into detail on, but this gives you the body of the function that you're going to be testing. I need to import assert throws, and then I probably need to import something else as well, but we'll see. I already imported assert throws. Why are you asking me again? Alright, what happened? It's imported there. Alright, well, I'll write the body and see if it works itself out. So let me try int a equals, what did I say? s.length divided by 0. Yeah, s.length divided by 0. And then what did I do here? The old typo. Okay, so this gives me the exception that I get when I run the body of it, so everything that's inside of these curly brackets. And it also asserts that an exception was thrown inside of these curly brackets. So if I have s.length divided by 2 in there, and I run this, it's going to fail on this line because it is expecting an exception to be thrown. And if I read the detailed error, it'll say expected an exception to be thrown, but nothing was thrown. And that's what gives you the power to also specify a more specific exception, like, gosh, I don't remember the name of it. The quickest way to get the name of an exception, if you've forgotten it, is to just run some code that has that exception in it, and in no time you'll find the name. So, that one's called divide by 0, but it's got a slash, but it's actually called arithmetic expression from the library. So I would have to say, let me see, it comes from the Java library, so it would be java.lang, and then it should be is there an exceptions library? Let me think for a second. I think it's just going to be arithmetic exception .class. Yep, that should do the trick. So if you were looking for that particular exception, I think that's how you would address it, but you would have to find its path within the language. They're all java.lang somewhere. They're all in the top level Java hierarchy. But anyway, all right, let's just catch the regular exception for now, and we'll try to see that the error that we get when we divide by 0 is that slash by 0 error. So we'll compare the text of the exception. We'll compare the text, so exception dot get message, and we'll compare it to what we expect, which is slash by 0. I'm reading that off from right there. Oops. Slash by 0. This also empowers you to write your own exceptions for your different methods and then pass them up and then assert in your tests that it's the exception that you expected and the message that you accepted. This is really powerful when you're building out an application that's user-facing, because you can figure out what kind of exceptions you're going to pass up to the user, what their names are going to be, and so on and so forth. So you can name your exception like client not found or something, and then the message that gets transmitted to the user ultimately is client not found, and then you can write a test that in some situation where a client is uncovered, that's the exception that you get. So let's do one more. I think this covers both of the major cases. With this you can test pretty much all of your functions. We sometimes call these passing tests that are good and successful and test the behavior as expected. We call these the happy path tests. And these, you call them the bad path or the unhappy path or something. The tests that test the exceptions that you should get. So it's called the bad path not because the tests are incorrect. The tests are correct, but they're testing the situations where the application should fail and making sure that it fails correctly in the way that is expected. So let's do a couple more. Let's do some more stuff with, let's do something with string. We'll call this the happy path test. And don't forget to add that test annotation to remind JUnit to do something with it. Alright, so s equals sandwich. I guess I should show you what happens if you leave that test annotation off. So if you just forget it, and then you run this, it simply will not run. It's as if it's invisible to JUnit. So it's just not going to see it. And you can easily tell that because this is running 3 tests. There's 1, 2, 3 right now. This guy not being caught. Alright, so s equals sandwich, string expected equals sandwich. Let's test the 2 uppercase functions. So string actual equals s dot 2 uppercase. And now let's assert equals expected and actual. Notice that those are the default names that it filled in for me. Very helpful. Alright, so looks good. We were able to test that sandwich was indeed converted to uppercase. One thing you might notice is that the tests here are not in the order that they appear, so it actually ran the string test second. They'll all run, so you'll see which ones fail out of all of them. But you suppose I should point out that they don't appear necessarily in the order that you wrote them. Okay, well, let's convert it back to lower then. So let's update expected to be sandwich. You notice that whenever I'm writing the expected cases, I'm almost always writing them manually. That's generally true. You want to be as manual as possible, but sometimes you do want to use some of your other functions that you've already tested elsewhere and proven are reliable with their test. That's perfectly fine too. So if I had a function that already worked and could produce for me the lowercase sandwich, that would work. Or what do I already have? Well, I have s, what it was originally in the first place, right? So why don't I just use that as my expected? I can say expected equals s. If I'm going to convert to lowercase, it should go back to what it was when it started. Right? So let's assert that again. It's also perfectly fine to recycle your variables like this inside of unit tests. It's also perfectly fine to have slightly crappier variable naming when it comes to your unit tests. They're not really part of the code, but your unit test should test logical blocks of expectations. It's probably bad practice to test both uppercase and lowercase in a single unit test like this. Ideally, they both have their own, and it should be pretty easy for a reader to follow along and see what you're doing. Sometimes you want to write out parts of your test with a little bit of a inline plain English explanation if there isn't one that's obvious from looking at the code too. Because the tests often serve as a kind of documentation of their own. It shows future programmers what you expected that function to do in different circumstances. Okay, one more. Let's see what other libraries can we test that belong to S. Let's do contains. Let's try a couple different contains variants. Okay, so Boolean. I guess let's do the right thing and write these in their own test. So this is string upper lower test epipath, and then I'll write a new one for string contains test happy path. Alright, so I've got sandwich, string to check. Let's go with sand. We'll check if sand is inside of sandwich. Alright, so let's check if sand is inside of sandwich. In this case, my values, my expectations are a Boolean. I can also shorten this whole thing and just bake the entire expression inside of the assert. So I want to assert that s dot contains, and then to check is true. So remember, if the stuff that's inside of the assertion evaluates to true, the test continues. And now I can check something else. Let's say I want to check which. I'll assert that as well. Okay. And then some test designers, some programmers will also opt for a very simple test like this to also maybe include some parts of the bad path here as well. So not necessarily just to make this part of the happy path, but also test some of those edge cases. Does it contain sand all uppercase, for example? Well, it shouldn't. It should be case sensitive, right? We can read the documentation of contains to find out. It doesn't tell us about case sensitivity. It says returns true if and only if the string contains the specified sequence of char values. So perhaps it does, perhaps it doesn't. We'll find out when we run the test, right? And it looks like it passes, so this assertion that it does not contain uppercase sand is correct. And then we can test maybe something random, like a bunch of characters, and we can test some things that are silly as well, like blank string. What happens when you test for a blank string? Well, it fails. Interesting. Why is that? Why is that? Well, every string actually contains blank string. So this is one of those weird edge cases that's helpful to document inside of the test. Here you might leave a note for future developers something like every string contains n contains the empty string. And then say what the empty string is. Because this is something that's not immediately obvious, and it's also something that's too much of a detail of minutia to actually include in the documentation for the contains method, hence why they omitted it. And let's see, let's check null. What happens when you try to check for containment with a null value? Well, whoopsie, I got into the string class there. Well, I get a null pointer exception because I can't call contains on a null value. So then I have to go back to my exception handling mechanism as well, and I'm going to check that this throws a null pointer exception. So let's be specific and say java.lang.null pointer exception dot class, and we'll include my function in the body there. Since this is actually its own sort of anonymous function, you actually have to redeclare everything in there. So string, let's call this check. There we go. Okay, so this is asserting that an exception is thrown, and then we should also assert that the exception's message is the one that we expect, which you don't necessarily have to do if you're already asserting that you're getting null pointer exception specifically. So here I already know what exception I got, so checking the message is kind of extra, but let's see, let's do it anyway. I think that's how null pointer exception is spelled. Let's see, it might be lowercase. Expected null pointer exception, but was null, so declare everything inside here again, and bool. So in this case, I have expected null pointer exception, but was null, so I guess the one that I'm actually expecting. I guess the error message you get with null pointer exception is either null, or the error I'm getting back is null. So probably it's the latter. It's probably that exception.getMessage is returning null. So it's possible that null pointer exception is one of those ones that doesn't have its own message. Let's see if I just return exception.class what I get. Yeah, I get string null, but was null. Alright, so we'll just leave it at this then. We'll assert that the exception occurs. We won't compare the messages in this case. And then we'll see that it passes. So we're just asserting that an exception has happened here. I guess let's do one more with a named exception, since that one was a little bit funky. I guess null was a bad choice. Let's do string out of bounds then. Let's do string out of bounds. That should be an easy one. So we'll write a new test. We'll call this string bounds. You can even call it something like string bounds bad path, or string out of bounds, whatever feels most appropriate. So in this case, I'm going to throw java.lang.string index out of bounds exception, and I'll do a string s equals sandwich again. Sandwich is only 1, 2, 3, 4, 5, 6, 7, 8, 9 characters long. So let's try to do char c equals s dot char at, and then we'll try to get the character at 15, which doesn't exist because our string is too long. Well, in that case, it will fail. So the test is successful because it fails as expected, but it should fail with a specific error message. So let's see what error message we get. It's something like out of bounds, question mark, but we're not entirely sure until we compare it. I don't remember it. So it's string index was out of range, and then it also tells you the number. So in this case, you might want to save the 15 to a variable. That would be best practices if you were actually writing code and not writing tests. And it's good practice for tests too. So let's go with int toTest equals 15 and use that instead, right? And then we'll describe our error message. It was, what do we have here? String index out of range, and then it should be the same number that I got. So sometimes your tests will similarly have customized error messages depending on the kind of exception that occurs. So if they have customized error messages, then this might not be sufficient. Like declaring, like we did up here, the null pointer exception might not be sufficient. You might get the right exception, but then get the wrong error message. So in that situation, you might want to have two layers like we've done here. You assert one, that you get the right exception, and then two, that you get the right message out of the exception. So this should pass. And then I guess the very last thing I'll show you before we wrap up is that if you try to catch the wrong exception, so here it was supposed to be string out of bounds, if I try to catch null and I get that instead, that's also going to fail. It's going to show that it expected a different kind of exception to be thrown by assert throws. Alright, that should be the basics, enough to get you started with testing the good and bad paths of all your various methods. So enjoy and see you next time.